So this is the MATLAB code for question 7. Starting from the code of line number 4 to line number 9, we declare the values of EM and EC for calculating the modulating index. Then the code of line numbers then is the time period, followed by code line number 11 is the equation of the modulator signal. The code from line number 12 to 17 is for plot the waveform of the modulated signal. Beside the code is the waveform obtained from MATLAB for modulated signal. Question part B is to plot the frequency spectrum. We use the FFT fast Fourier transform function in the MATLAB for plotting the waveform. The coding from line number 19 to line 25 is the FFT function coding and the adjustment of frequency domain, while the code for line 26 is to shift the zero frequency component to the center of the spectrum. Code from line number 27 to 32 is for plotting the waveform, and the result is shown beside the code. The last part of the question is to calculate the power efficiency of the modulated signal. The formula of the power efficiency is m squared divided by 2 plus m squared. This equation is typed as a code in the MATLAB, and the power efficiency is shown in the MATLAB command window.
From the coding, we can see that the amplitude of the modulating signal and the carrier signal have been write out. So we are using that to calculate our modulation index is using the amplitude of the modulating signal to divide by the amplitude of the carrier signal. For the time, we are using 0 to 10 seconds in the 1000 divisions. And down there, that one is a full equation for the M signal. Then we're using the subplot to plot a time domain graph. So for the S label, we are using the time, and for the Y label, we are using the amplitude. So for the half upper part is for the time domain coding. For the half below part, we are using the fast Fourier transform, because the fast Fourier transform it can convert the original domain to a frequency domain, because we not only want in the time domain but also in the frequency domain. So we are using the same method using the subplot, but for the S label we are changing. We will use in terms of the frequency, but the Y label is still in the same in amplitude. So I'm going to run my program. So there is for the upper part is the time domain and lower part is the frequency domain. In the time domain, we can see that there is the signal already been modulated. However, in the frequency domain, it shows the spectrum for the frequency, so we can determine which is the FC and the FM.
So this is the code for the amplitude modulated signal for question 9. So we just type in the modulating signal and the carrier signal. Then for the modulation signal, we use the modulate function in MATLAB. So the first column will be our input signal, and then the second column will be the carrier frequency, and the third column will be the sample rate, and the last column will be the method. So in this question, we use the AMDSB, stands for amplitude modulation double sideband. Okay, so this is the code for the graph. So after running, the code will be like this. So we will get the amplitude modulated signal like this. So for the frequency spectrum, the code will be like this. So we'll be using the FFT function to Fourier transform our signal. Yeah, then this will be our code for the graph for frequency spectrum. After running the code, we'll be getting this. Yeah, this. And then the last part will be the modulation index. So nothing new, just using the formula. So M1, M2, and then the effective M, and then lastly we display the M. So we'll be getting this figure 0.5385. Okay, that's all. Thank you.